All right, so we're back talking about inequalities. We're in section 1.7. In the last video, we talked about what to do with linear inequalities. So now we're up to the quadratic inequalities. So following along in the handout, if you'll follow along with me there, we're to the quadratic part. So we talked about linears in the last one, and we learned really the only new thing about linears is if you divide or multiply by a negative, you'll flip the inequality. So now we're on to the quadratic. So here's an example of a quadratic with an inequality. Inequality means less than or greater than sign. Okay, and if you're reading along with me, it says to solve a quadratic inequality, it's at the bottom of the second page. You will solve the quadratic with one of your four methods. We have four methods for solving a quadratic. As you'll recall from our earlier section, we can solve the quadratics by factoring, but not all of them are factorable. But if it is factorable, that's one method. You can use the square root property in certain cases. You can complete the square, or you can use the quadratic equation. So any of those four methods, we have four methods for quadratics. Use that, solve your quadratic, and then we will follow up. So then it says the new twist, second sentence, the new twist is you must follow up by thinking of these solutions as only the boundary lines that cuts through the x-axis, and then it cuts it into different regions. Then your job is to determine which regions are solutions in the inequality. So we'll take a test point within each region, and if the test point works, we'll say that region all is a solution. If it doesn't, we'll say it's not. So here's what it looks like. Here's an example. Here's a quadratic. Just pretend like this is an equal sign and solve your quadratic with one of your methods. This one is factorable, so I would pursue that. If you hate factoring, you will do A is 1, B is -1, C is -12. Plug it in your quadratic formula to get your solutions will also work. But you can see it does factor. Then by the zero factor property, we can set each factor equal to 0, giving us our two solutions. What would be the solutions to the quadratic? Just like we used to do in the earlier section. What is new is once you find those solutions, you show those cutting through the number line at -3 and at +4. So it creates three regions, 1, 2, 3. And then our job is to see which regions solve or work in the original inequality. You can use the original inequality form, or if the original is always the safest place to go back and check. But if you're sure this is right, this is also another place to check. But what we're going to do is take a test point out of each region. So the easiest test point is always wherever 0 lies. So 0 would be between -3 and 4. Now you can take any test point you want. 1, 2, 3, 3.5, 3 3/4, -1, anything in there. You should get the same result. Either it works in that region or it doesn't work. If you got the right boundary lines. All of this is either all true or all not true. So when I check with 0, I'm checking for that whole region. So if I put 0 in for the x to check to see if it works, 0 squared -0 -12, I say, does that work? 0 minus 0 is just 0. So we're really asking, is -12 less than 0? And think about that for a second, and absolutely, -12 is less than 0. So that, we would say, works. It solves that and is part of its solution. So it works. So that means I should shade that region. Now, to be thorough, and if you do view the example in your MyLabs, it will ask you to check all the regions. So just to say we did, let's check 5 and show that it doesn't work. So if I do 5 back in the original problem here, 5 squared -5 -12, is that less than 0? That's 25 minus 5 minus 12. You feel free to use your calculator. That's 8. Is 8 less than 0? And no, it is not. So 5 does not work to give it a real solution, something that works. So no. So it's not shaded. Then checking something in this other region, like maybe -4. You could check -5, -100. Anything in this region, they all should go together. So, but don't use the boundary. It has to be something outside of it. So let's say we check -4 squared minus -4 minus 12. Is that less than 0? and then do a little bit of arithmetic on your calculator. That's 16 plus 4 minus 12. Well, that's also, I think so, 8. Is 8 less than 0? Again, no, that is not true, so we shouldn't shade that region. So the middle region is the solution. So, and there's no line under it, so we're using parentheses. So that all of that region from -3 to 4, that's where the solution set lies. Sometimes it lies in the wings, the 2 outer regions. It's either in the middle or the 2 outside parts, though. You can kind of count on that just because the properties of a quadratic make a parabola, and it either is less than in the middle of it or the wing parts. And we'll talk about that more when we think about what the graph looks like. But for now, just know if you check where 0's at, you can kind of just go by that. It's either the inside or the 2 outsides. All right, so you've got one to try, so please pause the video and do that. Try to practice one where you fly solo. It really does help you to understand it at a better level if you participate. And also this is helping us review factoring or using the quadratic formula, kind of getting us to be better at that. All the time that you practice that, you're going to get better and better. It's a practice or doing the exercises that helps us improve on these. So I like to factor, you know, on these and think about the little puzzle. But if you are more methodical and prefer the formula, that's what you'd be doing here. Feel free to race me on this if you want to try to do it by the formula instead. I know to get the first is 3x squared, and that's pretty much the only way first times first, because 3 is a prime number. To get 4, it's either 4 times 1, 2 times 2, or they're vice versas. I can kind of foresee that I'm going to need a 1 times 4, so when I FOIL it, I need a 12, and then a 1 to try to get this larger number there. 2 times 2, I could try that, but I know that doesn't work. And I need a negative here and a positive here. But again, you can just trial and error that. It's like a puzzle trying to find where the pieces fit. Or if you're one of those people that really tries to measure and see, do I really think it fits? Or just throw it in there and see if it works. If it doesn't, keep moving it around. So I'm good with doing it that way. But notice that, let me show you this. When we FOIL this, first is 3x squared per the design. It should be. And then the L, the last, needs to be -4. So we pick those numbers to be that. What we're trying to figure out is the one right combo where the inner and the outer, when combined, gives us the right middle term. And so we can see that does give us the right -11. So we can deem this factored correctly. If it's factorable, then we set each factor equal to 0. And then solve each one of these linear parts. You'll get -1/3, +4. Then that makes only boundary lines. It cuts the number line at these 2 points, -1/3 and 4. And then our job is to figure out, is it the middle region that works or is it the wings, the 2 outer regions? And the way we do that is with a test point. Now, if you're doing view the example, it says just check every one of those. And to be the most cautious, the most thorough, you would check each one. But if you check 0 and you're real careful with your checking, that's really all you have to check. If you check 0, it's between the negative and the positive numbers, definitely in that region. It's not always in the middle, but it is in these examples. Plug it back into the original. It's an easy number to check. You see, x squared, that'd be 0 times 3. Zeroes that out. -11 times 0 for that x. Zeroes that out. So all that's gone. So you're really just saying -4, is that greater than or equal to 0? Is that true? Just really that last number. Is that true? If you're checking 0. So no, -4 is not greater than 0. So that failed. So that leads me to believe it's the 2 outer parts, the wings. And again, on view the example, and to be thorough, check something. Like check 5, something out in that region, and it should work. It's a little harder to check though, you know, than 0, so that's why I'm kind of lazy about that. But you could do your calculator, use your calculator to do that. and see if that works. So that is 25 times 3, 75 minus 55 minus 4. And think about that. And that does come out to be bigger than 0. So that checks out. That works. So the 5 works. And then if I check anything out here, it should also work. So how am I going to write those two answers that are split? That's new for us. We've got two answers. This answer is negative infinity up to negative 1/3. Line under it, so use a bracket. Then this is the new thing. Use a U. U for union. It's kind of like plus in math. So union with this region 4 to infinity. And then that's how we would write when it's the two outer parts. The two pieces, you use a U between it. And that's your answer there. Another thing we can do, and I just want to kind of talk to you about this as we're getting ready to finish up chapter 1. When we get to chapter 2, we will be graphing these things. And a quadratic equation always graphs to be a parabola. So if you want to use your graphing calculator and type that in, what you'll find is when you sketch that graph, it crosses, let's see, it's a positive parabola. Looks something like that. It crosses at negative 1/3 and it crosses at 4. So what it's really asking you is, if you were to graph this as y equals, doing the graph of this, all quadratics graph to be parabolas, this U shape. So it's asking you, when is this parabola above 0, greater than or equal to 0? So since it's an upright parabola, and that's where it crosses through the 0, where it crosses the x-axis, that's its solution. Solutions are basically the x-intercepts in graphing. So the solutions to our equation, negative 1/3 and 4, which you might be able to actually see on your graphing screen and help you out with this as another method. And, you know, using your graphing calculator is not against the rules. Anyway, it's asking you, when is this graph above 0? And that's the wing parts here, right? And again, this is kind of getting ahead of ourselves. You won't see this in the view the example on 1.7, but I'm just kind of telling you ahead of time, that's an easier way to do it if you want to pursue using your graphing calculator. And we'll look at that some more as we get to the graphing, but just thought I would mention that while we're on this topic. All right, so I think I'll stop right there. So the last topic in 1.7, we're going to talk about what to do with the fractions whenever you have an inequality. Again, the theme of 1.7 is the different types of inequality. Linears, quadratics we just saw, and in the last video for this section, we'll talk about what to do with the rational inequalities. Those are the fraction inequalities. So we'll come back to that on this next video.